Okay, welcome to this tutorial. We're going to use Microsoft Excel to work with linear population growth models, both the implicit and explicit type. And we'll start just by setting up the problem. This is a linear population model with initial population, which we denote with P0 equal to 125, and common difference, which we denote with D equal to -4. We're going to start by making two columns. The first column is n, the second column is p sub n. Now, if we want to make this n in the subscript, we can double click and highlight it, and then we can right click on it and choose Format Cells and Subscript. Now we have p sub n. I'm going to highlight the A and B columns and select the center align so that my columns are centered. And where my text is, I'm going to click on that and put that back to left align so I can see everything. So we want to generate populations here. We'll start with a population of 0, hit enter, 1, hit enter, hit 2, hit enter. Once you have 3 rows that are set up, Excel will recognize the pattern if you highlight the 3 as I have, and then drag the corner. See how my hand changes to a crosshair? I will click and drag, and Excel understands the pattern. And notice the little number that is showing up. It's showing you what number it's going to be putting in those cells because it continued the pattern. Now that we have our generations set up in the first column, we want to create populations for the second column. Well, P sub n means the population for generation 0, and this is where n is 0. So we know this population, that is 125. So we can say that this first population number is 125. Now we're going to use a formula in Excel to generate future populations. Anytime you want Excel to do the math, you start with an equal sign. And with recursion, we learn that we need the previous data to generate new data. So it's looking up what's in B4. So we see we're in column B, row 4. It's going to grab that 125. We hit -4 because our common difference is -4, and we will hit enter. So it gave me 121. Now, if I click on this one cell that I put the formula in, and you'll see the formula up here in the formula bar. So I'm going to hit escape to get out of that. If I click on this one cell and once again hover over the corner when my hand changes to a crosshair and click and drag, it will use the formula to generate future populations. Now, if I wanted to know how many generations until the population goes extinct, we can highlight the column and the population and continue to drag. And we can keep doing this until we reach a population of 0 or the first population that is less than 0. And we see that it takes 32 generations for this population to go extinct. So now we're going to do this again, but with a linear function or an explicit model. And here, for whatever number I put in for n, it will generate the population under P sub n. I don't need a complete table with previous data. I can jump to any generation. So we want to rewrite the recursive model as a function. So we're going to follow the model or the linear equation format of y equals mx plus b. But now we're saying m is the slope, which means the common difference, the rate of change that keeps repeating. So that means that d is going to be our slope, and b is your starting point or your starting value. Well, that's p sub 0, 125. So we're going to write here equals -4 times, but instead of x, our variable is n. So we're going to click on the n cell, and we're going to say plus our starting value is b, which is 125, and we hit enter. And we see that when n is 0, we get 125, just like we have here. We can check this with another value. I can plug in 12 for n and see that I get 77. So now I can come up here and type in 12, and we get 77. So this is the explicit model. I'm going to merge this. Type in the word explicit, and above here, where we have the recursive model, I'll highlight those two cells, merge it, and type in recursion. And we see that this explicit model is not dependent on previous data to generate new data. I can just type in a generation and find what its value is. But notice what happens here. I'm going to delete one row of data here. So for row 7, when I right click on that and I say delete, look what happened to all of my population. All of them became uncalculated because I can't find future populations without previous. We need everything. And that's the drawback to recursion. So I'm going to hit Command Z to undo that, put that generation back in. But you see that as soon as one generation is missing, it gives me, I just deleted that cell. Now it's giving me erroneous data, where if I took out the data altogether, it gave me a reference message. And all of this is showing us that recursion needs previous data to get future data. Each generation is dependent on the previous one. But explicit models, which are functions, are not connected to previous data. It's a model that I can plug in a generation and jump to it. Often students say, well, why would we bother with recursions if we can just do things with functions? And it's a great question. And always in math, we use something that we're familiar with. Right now, we're learning about population models using linear equations, which is something we're familiar with. And we're showing you how recursions work and how they generate the same populations as our function. So again, if I were to type in 4 for n over here, I get 109, which matches. So we see that we've done our recursion correctly. And the reason for this is that not all population models can be expressed with a nice, neat, explicit function. Sometimes we have no choice but to do this using a recursive model and a year by year or generation by generation tally of how the population changes. So we're learning to use recursion, we're relating it to something we know, and we're tying these two together. But if we move on to other models, such as the Fibonacci sequence, you would find that you would have to use recursion because the function or the explicit model is not easy to find. It's actually very difficult. And we're just going to be better off using recursion for models like that sort. So this introduces you to Excel, how we can use it to create models of the implicit or recursive type and models of the explicit or function type. Now, if I wanted this to generate a bunch of data, I can go 0, 1, 2, and I can continue this pattern like I did before. And I can take this function and copy and paste it. And I can use either of these now to plot the points for my data. So if I wanted, let's highlight the n and the p of n, and let's get in 20 generations of data. If I wanted to use all 20 generations of data to plot the points, I would highlight that data and go to my insert, chart, and scatter plot, XY scatter. And we see we get a chart of this. And we see that the population is decreasing on the chart, and it just gives us an easy way to use Microsoft Excel to give us graphics that we can include in reports or websites. So that's the end of the presentation. Watch the video, use it to help with the homework, and send me questions.